Welcome to the webinar. I will unshare this page, which is just a little page that shouldn't be there, and I will start sharing my presentation. My name is Raquel Thompson. I work at North Anglia International School in Hong Kong. I used to be head of maths in my previous school, and I was so for 7 years. And I gained a lot of experience, especially a lot of experience through the Maths Hub that I worked at, which was the Wandsworth Wandsworth Council. I learned so much from them, and my wish now is to try to share a little bit of my learning and my experiences in the hope that they will be useful to you. During the webinar, I think, for my purposes, so that I can manage the information. If you have any questions, please feel free to type it on the type it on the chat, and I will be able to see it as I deliver the webinar. If I'm going too fast, do let me know. I am going to try as much as possible. This is the 4th webinar of 5. The first 3 were quite based on theory, a lot of lots of theory, lots of groundwork, but hopefully now, especially if you've joined in a few of them, or all of them, that would be amazing. Then what I would like to do more today is a bit more practical. So hopefully towards halfway through this webinar, we will break out into rooms and kind of do a practical side, see if we can do a bit of groundwork on differentiation together as a collaborative piece of work, and I'll show you how we will do that soon. So starting off, differentiation less is more. I'll explain. I think towards the end I'll explain why I chose this title for the webinar. But for now, let's just start it off with a quote that I find. I don't really love reading through PowerPoints, but this quote really encapsulates everything that that I consider important about differentiation. So I am going to read it to you, just this one. So the ultimate goal of differentiation is to meet the needs of the varied students in a classroom during instruction. This becomes manageable, that word manageable, really important, if the teacher can create a single question or task that is inclusive, not only in allowing for different students to approach it by using different processes or strategies, but also in allowing for students in at different stages of mathematical development to benefit and grow from attention to the task. So to me, it's all about making a task, and we'll go into the anchor tasks and how I would see, or how I've seen to me, the best maths lessons happening. It's kind of making it manageable for the teacher in order for assessment for learning to happen effectively as well, without having to resort to those typical chili 1, chili 2, chili 3, hundreds of resources. No, just keep it simple, but that task is not as simple as it looks. It's really well thought through. It's inclusive. It means that everybody can access it, not just the high ability, not just the lower ability. Everybody can access the same task. So it makes it manageable for the teacher, but also for the children as well. It makes them all feel like they can do maths, they can achieve maths, they can benefit from listening to the children who are collaborating in the lesson, and everybody can benefit from growing, can benefit from just the listening, and also listening to the different processes and strategies that each child and teacher comes up with to solve the same problem. So that's kind of the overarching idea for today. A few other quotes which I will just literally fly through because they come from the NCTM article. This will all be shared with you at the end, but it's just talking about how children are, the concept that children are supposed to become fluent in the fundamentals. They need to be able to reason mathematically, and that they should be able to apply those mathematics to solve problems. We have the NCTM talks about intelligent practice, which is all about variation. I covered that in my last webinar, so hopefully, if you want to watch it, or if you want some more information on that, feel free to ask at the end, and I'm happy to send you the recording of that. And obviously the pupils who grasp concepts rapidly should be challenged through rich and sophisticated problems before any acceleration through new content. What that means, you know, in the old days, and I do believe that most schools and teachers nowadays don't do that at all. I mean, the old days is, oh, this Johnny knows how to multiply by 10. So I'm going to extend them by making him multiply by 100 in this lesson. But the objective is to multiply by 10. So we need to get away from giving a different objective. We should differentiate or extend within the same objective, just going a bit deeper into it. And we'll go into, in a minute, into how we can do that. Now, how should you differentiate in the classroom? Well, there are lots of ways. Oh, am I not sharing my screen? Sorry. Sophie's just saying, I'm not sharing my screen. Is that right? Am I not sharing my screen? Oh dear, this is not going well. Hold on a second. I should be sharing. Bear with me. Thank you, Sophie, for letting me know. I should be sharing my screen, yes. Hold on one second. How about now? Can you see something? Hopefully I can go back through these. Actually, you didn't miss much. Thank goodness you've told me. Can you see the screen now with the questions there?
I still can't see anything, Raquel.
Oh dear.
I don't know if it's just me or anyone else as well.
Other people can't either.
Well, I can't see it either.
Oh my goodness, why is this?
I'm here.
Okay, I will do my best. Let me try a different way. Share. Try again later. Oh dear. How am I going to do this without sharing my screen? That's going to be a little bit impossible. Right, how about if sorry, apologies for this. Let's try that again. Oh my, I don't even know what I'm sharing now.
Yeah, we can see it now. It says differentiation. How can you show differentiation in the classroom?
Can you see it? Ah, perfect. Yeah. Okay. And you can see questioning, open questions. Love it. Thank you. Yeah. Great. Thank you so much. Oh, that would have been a disaster not being able to share. Okay, great. Okay, so I'll start again. So how can you differentiate in the classroom? To me, the most useful tool is the questioning. How you start your question with that open question, with that really a question or a problem solving situation where the children have to communicate with each other. They have to try to solve it with whatever tools they decide that they want or that are available to them. Then also, how do you differentiate through the fluency and the reasoning problem solving tasks that they will do in their further practice. I call it further practice. I don't call it independent work, mainly because even though it's independent of the teacher often, it could be a collaborative piece of work. So I've decided to call the independent work further practice. So that's when you can use questioning. And what I mean in terms of differentiation is what questions can we ask at the different stages of their learning, of that progression, that will ensure that they can progress, in fact. And obviously the question is also very much involved in variation, which I won't go over today, otherwise we would be here all day. Then obviously you can differentiate through the resources. So some children might be able to access the same objective, but they might need some manipulative, some hands-on physical resources that they can access, that they can just do the maths, and that will allow them to understand the maths. It might require some modeling by the teacher. It could be a modeling still using manipulatives. It could be modeling using a pictorial model. It could be any models that you can think of, anything that will support the learning of that objective. It could also be in terms of presentation. You can differentiate to different children. So for a struggling learner, you might present something in a visually simpler way than to a more higher ability learner, because they might be able to access the information or to spot patterns in a different way. The other way that you can, if this moves, that you can offer differentiation is through support, of course. You can, some children, in order to achieve the learning objective within that lesson, may need adult support or may not need any support. Sometimes it may be that the differentiation is that you use peer collaboration. It could be that it's mixed ability or not mixed ability, and that's how they achieve either the challenges or support work. And obviously there is, throughout the lesson, as the children go through fluency and the reasoning problem solving, they will then be differentiated themselves through the outcome. How deep have they gone into that learning within that lesson? And that is a natural flow that happens. It's not, well, you can control through the questioning and through the tasks that you carefully planned beforehand, but it kind of happens naturally. Now, oh, there's people waiting in the waiting room. Bear with me before I continue, before I explain this one. How do I do this? Participant, oh, here we are, admit. Okay, apologies for that. Right, so this, my colleague Fikra at North Anglia as well, he shared this pyramid with me, and I really like it because it really highlights the hands-on approach to learning, that practice by doing, discussing, collaborating is really the way forward to maths learning, and it really is a good way of differentiating if you are trying to get, especially the children who don't find maths so easy, to get them to learn and to achieve the learning objective at the end of that particular lesson or at the end of a particular unit. Someone's got their microphone on. If you could turn it off, that would be amazing. In fact, I am going to mute you now. There we are. Okay, so when I first heard of open questions, anchor tasks, I was in my old school. We were trying to introduce a mastery approach to, that was a long time ago, trying to introduce a mastery approach to learning maths or teaching maths as well. And I was told, oh, we need to just create some open questions. You just need to get some anchor tasks ready. And I remember feeling completely overwhelmed. And I think that happens when you don't really have the experience and you don't really have a model, like a waggle, to show you how to do it. So if you are, I would say, if you are at the beginning of your mastery journey at your school and you don't know much about anchor tasks, I would suggest that you try to find a scheme that could help you to start off. In my old school, we used Maths No Problem. That helped, but then it kind of after a while, and not a long while, after a short while, as we became confident with creating these tasks, we thought they're actually not exactly how we want them to be. Now we know how to do it. We're going to tailor to our classes. We're going to personalize them so that the children become more actively involved. And so we started making ours. But how, you ask? How do you do it? Well, these are some suggestions of how to do it. There are some common strategies for creating open questions. One could be that you turn around the question. So instead of asking the question, you just ask, you give the answer. So the answer is 12. What could the question be? I know this is a simple one, but there could be so many questions that could come out of this particular, just by turning around the question. Looking for patterns. So you start at the beginning. What's the same? What's different about these things? What's the odd one out? Which one doesn't belong? Always, sometimes, never. I find that they find it really, really hard. Even the children who find maths really easy, the fluency side of maths really easy, they find this particular one really difficult because they're so reluctant to prove their maths, aren't they? They just want to say, yes, it's true, no, it's false, but they don't really want to prove it. And when you're trying to prove an always or a sometimes or a never, especially a sometimes, you have to have evidence of both, right? And you can't just have one piece of evidence for each of them. So it's important. It's a really difficult one, but it requires training. But once they get to it, it's actually it gives you a great insight into their mathematical brain and how they think, and the examples that they choose to prove to you that it's always a sometimes never, also indicate the depth at which they are at the moment in their mathematical journey. So questions like that, really great to see, to really assess where the children are in terms of the mathematical learning within that particular lesson or that particular objective. Another one, missing number questions. So by replacing a number or a shape or a measurement unit with a blank, I think you've all seen these before. Asking for a number sentence, for example, I could say, can you make a word problem or a number sentence, and you have to include these particular mathematical words or this particular mathematical symbol. And it's harder than you think, but if they can't do it, then it shows that there's some gaps there. And again, another great way to do a bit of assessment for learning and to in order to then fill in those gaps at a different time. And then another one that I love is generalizing. So it's something that is not for you to say. It's not for me to say, this is how you find fractions of amounts. You take the total, you divide by denominator, and then you multiply by the numerator. It's the children that discover it by doing the maths. And then they might come up with sentences. What I mean with STEM sentences that generalize are sentences that always work, no matter what words or numbers you put in, they always work. They're always true in a way. So if I put in brackets what it should be there. So if we were looking at fractions, the denominator tells us how many equal parts there are in the whole. And so the children, if they come up with a STEM sentence like this, and they will have to come up with it, it's not for the teacher to tell them, then they will always know, they will always understand that the denominator actually talks about the equal parts in the whole, and they will not find fractions of amounts hard, for example. Please let me know if I'm going too fast. We will be getting to the practical in a minute, but I thought perhaps it would be good to share with you as well, not just how to create an open question and an anchor task, but also what I believe, what I've seen, and what I believe is an effective approach to a maths lesson. So to me, starting with an anchor task, and by no means do all lessons have to start with an anchor task. An anchor task is there to start almost a learning journey on a particular objective. So if the objective will take 2-3 lessons, then the anchor task is just that hook, really, to get the children thinking and get them to learn, and for you to assess where they are within that objective. So starting with an open question, a problem to explore with their peers, having a long conversation, the TLA is involved, walking around the room, asking, listening to their conversations. What language are they using? Do they need manipulatives to make sense of the problem? And you also, if they are already making sense of the problem, then you have some questions up your sleeve to try to take that further, to see how much that they can go already at the start of the lesson. The next bit would be a guided practice. So that's when the teacher scaffolds through carefully selected questions, scaffolds the learning. The children might be spotting patterns and explaining their thinking. That really is great to see that there's a lot of ping pong. I don't know if everybody knows what the ping pong is. It's basically you kind of discuss a little tiny step of a skill, and then you ask children to practice. Let's feedback. Teacher get the next step, do another practice, feedback, and that's kind of what ping pong is all about. It's not just the teacher teaching at the start and then you go off and do your work independently, be quiet, and I'll mark it at the end of the lesson. It's this constant conversation, this constant checking and assessing that the children are all following, and making sure that as you do that, if someone needs support, they're being supported with the right tools, with the right person, or maybe you need a peer to help out, or if they need challenge, that you are already providing challenge so the children are not getting bored in the lesson. The next bit would be obviously the further practice. That's when they're going to be applying skills. Now, the further practice could be happening as the guided practice is happening. So it depends on how you teach the lesson. So it could be within the guided practice, but it could be after the guided practice. It depends on how you structure your lessons. And then the last thing is plenary. Lots of people do plenaries. I do them all the time, but I tend to prefer mini plenaries because we're teaching, well, if you are teaching little steps, then you will be assessing those little steps, whether the children have got them at each stage. So you will probably be doing more mini plenaries. I put a question mark because it's kind of up to preference really, and how you decide that you want your lesson, the pace of your lesson to go. Now, I'm going to show you a modeled example, and then we will do some practice. These are two examples of possible lesson starters for a Year 5 lesson on fractions of amounts. And I just want to know what you notice. I just want to engage with you a little bit more. It's been me talk. Could you on the chat perhaps type up, what do you notice? What's the same, what's different? I'm using the same kind of, trying to use the same interactive questioning that you would use with the children. What is the same, what's different about the two different versions? You can unmute your mic if you prefer to speak as well, but it'd be really lovely if someone could share, say something so we can move forward. So there's more visuals on the second one. Both have visuals, but the second one more so. What about in terms of the questioning? What do you notice? The first one is more fluency focused and the second one is more reasoning focused. Yep, I agree with that. I'm not asking whether one is better than the other at the moment. We're just, and this is the discussion that you would have with the children as well when you ask what's the same, what's different. We're just noticing what is there, what can you see? Okay, now this, you are right, this is, I don't know if you've noticed, but on purpose, this one doesn't have a learning objective. It is, I know that there are schools that really want to have the learning objective at the start. However, I don't always want the learning objective to start off with. I want the children to find out what they're going to be learning about. Often I do share the learning objective. It depends on the lesson that you're trying to teach. So I have, on this one, I've on purpose not included the learning objective. Here is, you're right, it's more of a fluency type of questioning. It doesn't really give much in terms of an ability to explore. They are very simple, direct questions. What is 3/4 of 36? What is 2/7 of 21? And what you're doing in this type of starter really is assessing what they know already. But what I'd like to put to you is a different way of starting your lesson, in a way that you explore more how they think, how they see number, how they actually think outside of the box. And so here, you know, they might say, well, I can see that 2/3 of 12 is related to this one because I know that 3 is the denominator, is the number of parts, and I've colored in 2, so that kind of is related. I can look at 4/6, some of them. Bear in mind, this is a lesson that would have been taught after teaching them equivalent fractions, and we've already done multiplication of fractions by integers. So it's nothing here is new. It's just bringing their attention to relationships between different areas of mathematics that don't always necessarily come up in a fractions lesson. Why do you think I did do this lesson? Because I wanted to practice so that I could do your this webinar with some experience of it as well. Lots of the children couldn't really see the point of this clock here. And I wonder, can anyone understand why is it that they couldn't really see why that clock was there? It's not really it's not really directly talking about a fraction. Usually you represent fractions with bars, and you have chocolates that you can break apart, and you have perhaps if you were lucky enough to be taught with part whole models, you will be shown part whole models, but you don't really talk about really fractions in different ways, in different contexts, really. So yes, Amy, they probably can't see that they can't see that the clock is split into 12 parts. An analog, an analog clock, of course. A digital clock would have 24 hours if it was a 24-hour clock. But we're looking at an analog clock with 12 parts, and a child in my class then said, well, and he explained to the class, which was more powerful than me explaining it. Well, what I did was split the clock into 3 parts, and so I knew that I had to draw a line to the 4 and draw a line to the 8, and it just means, and then I would color in all the way up to the 8. So many see the clock split into quarters, exactly, and this is our fault because we just talk about quarters, and actually clocks can be seen in different ways, and that's the point of this kind of activity, is that just to broaden, to deepen their understanding of number, to broaden their ideas about fractions even. The other thing, let me just show you the questions that I had in up my sleeve, really, as I was showing them this task. Obviously, most of the representations were aimed at all students, apart from the clock. I think that was the one that was trying to kind of get them to think outside of the box. But I always had, every time they were talking to me, and bear in mind this was difficult because it was an online lesson, it wasn't really a lesson in person, so not so easy to manage, not so easy to gauge whether they were all engaging really with this, but we tried our best. Can you explain how you know that one is related to the other? And they had to explain, oh, there's so many parts, and using the mathematical vocabulary, really wanting them. I didn't say, oh, there's 3 there and there's 2. Well, there's 3 what, bananas? Always try to encourage that mathematical vocabulary to always come into their explanations. What was your partner's strategy? If there was a strategy that was involved in finding out how they relate to each other, what was your partner's strategy? Of course, that question I couldn't ask yesterday, because they couldn't talk to their partner as such. But there's just so you can see what kind of questions that could be asked. Then I could have another question, just to take it a little bit further. My friend says that August could be included in this group. Is he right? So they could think, is he right? I'm asking you now. Could August be part of this random group of representations? Could it belong, really? If yes, why? How do you know? So this is the kind of question that, yes, so 8 out of 12 months, right? So it's kind of, again, if they don't know that a year has 12 months, which I hope by year 5 they do, then they wouldn't be able to access that concept. But if they didn't, there's always someone in the class who does, and that person will explain. And so the child who didn't know, at least, even if they didn't know about the 2/3 of 12 being 8, they've learned that there's 12 months in a year, and that's something else that there's a gap that was bridged there. Is there another example that could be included, for example, so that, you know, when you can think of your own examples, you're showing greater understanding. Thank you, Fiacre. Absolutely, making relationships will definitely show greater understanding of the topic. Is there an example that would not fit with this group? So coming up with a non-example, that came up, we talked about this in the variation webinar. And what could a word problem for any of these representations be? Something that Yale students find it very tricky. They might be great. We have lots of Yale students in our school. They might be great at maths, the fluency side, and the computing side of maths, they are fantastic. But then it's the mathematical language, the putting it together into something that makes sense in a word format, that's where they struggle. So that's another way of differentiating and challenging those students. Now you can do all of this at the start of the lesson, and this is exactly And then you can assess in the classroom more easily than online. You can assess where your students are. So then you will, another thing that I wanted to teach. This was
just a question.
Sorry?
Just a question on that. So you're using it mainly as a pre-assessment, is that right?
Yes and no. I use it as a pre-assessment, but also as a way to engage the children in the learning of this particular topic.
Yeah.
Like it can be, if I go back to the other example, this one here, it can be so boring doing questions like this every day in and day out. But if you are presented with something a bit different that makes you think outside of the box, perhaps you see maths in a more fun way, and that may give you the excitement to want to learn maths, even if you think you're not very good at it.
Yeah, like a hook. It's a bit like a hook, like
exactly.
as well as a pre-assessment. Yeah.
Yes. Thank you. Please do keep asking questions. I like that. So then I hooked them up in the lesson, I hope, and then I wanted to teach them something that sometimes you don't just need a process to find fractions of amounts. Sometimes you can just use the previous question or knowledge, other knowledge that you already have. And so I asked, can you find a third of 12? And all of them, without fail, showed me the process. And so, I do 12 divided by 3, which is 4, and then multiply by 1. Do you need to multiply by 1? So we kind of explored that a little bit more. What facts did you need to know? So do you need to be really good at your times tables? Yes, you do. So we explored that. And then I said, well, how do you find 2/3 of 12? And again, with no exception, all of them went 12 divided by 3 equals 4 times 2 equals 8. So, well, could you find that in a different way? Well, even though I had already talked about 2/3 in a previous question, in that all of them went through that. So that's what they think you want to see. They think you want to see them computing the maths. I said, well, is there anyone with a different method? Did anyone use a different and more efficient way without having to work it out? And obviously there's someone who came up and said, oh yes, I can see that there's 1/3 and there's 2/3. This is the same total. So I just have to multiply my answer by 2. So if this was 4 here, I just multiply by 2. Oh, okay, so the answer is 8. Excellent, okay. So how do I find 2/3 of 24? What do you notice? And at this point, I now have more people listening, because now some of them already are starting to be geared up to, and like listening to kind of thinking outside of the box, not just computing, processing. Okay, okay, let's see what's the same, what's different. Oh, it's 24 is double 12. Okay, so maybe what should I do? Or, okay, I'm going to be doubling that then. Okay, yes, fantastic, great answer. What about 4/3 of 24? What do you notice? That was a bit harder. Some of them didn't quite, even though we've done improper fractions, they didn't quite see that. But again, we shared the method with the partner. Is it the same method? Is it the same? Do you have to do the same? But I mean, really all they needed to see, and that's what they noticed, there's 2/3 and there's 4/3. They could have just doubled the answer. And then came questions 5 and 6. And I said, well, now how do you find 3/4 of 24 and 6/8 of 24? And at the end, they worked out that actually some of them did indeed work out again the answers using the process and the method, but some of them noted, 3/4, 6/8, they're equivalent fractions. Okay, so they're the same. And it was explicitly showing them that they can use and apply their skills. They can use the previous answer or previous knowledge to bring into the new context. And if we do this often, then they will start doing that without our help. Then at the moment, and we are using the White Rose Premium resources. So I moved on to the independent or the further practice tasks. And we tend to base our further practice on these kind of worksheets, but I wouldn't take them as, this is just the base. This is, I just look at the worksheet and go, okay, what, based on what I started, based on what the children have given me, what am I going to ask them to do? And so I've adapted that we use Seesaw in our school. I don't know if you use that as well, but I've adapted to question 1 and 2. The red are the fluency side of questions. Some children did only question 1. Some children I sent them to do question 2 only. Then question 3, 4, and 5 are reasoning, problem solving. And then I had collaborative challenges where they are high ability questions. They are high reasoning questions, but I didn't feel like they could get on with them by themselves. I thought that they needed a bit of collaborative work first. So I gave them a collaborative challenge and then another challenge, but that one to try to do independent, which was similar to the previous ones, but this time the challenge was to do it by themselves. How did it work? If you are interested, how did it work online? I created some breakout rooms and said, you children, I know exactly, and from the conversation at the start, I knew exactly who to send. You go to this breakout room, you're going to work on the collaborative challenges together. You children are going to go with the TLA to work on reasoning and problem solving. These are children who I think I was happy with the fluency that I've seen already. I don't need to see any more. I just want them to actually focus on, get on with reasoning, problem solving, so that they can feel confident that they can also access and achieve them in the lesson. And then I stayed with the group of children who really were not getting it, who needed more visual approach to these questions. So I do a lot of bar modeling, yes, a lot of bar models, a lot of coloring in, and trying to build those relationships between questions as well. So that's how I did the actual lesson. Now, in your own classes, you may have 2 options. Either you have to kind of slow down, and like I did, I didn't really slow down. I was lucky enough not to have to slow down, but the low ability will spend more time on the carpet, in this case on a different group, and you use bar models or manipulatives, and then they start making sense of it. Or you can even find that there might be prior misconceptions that you weren't aware of, or you hadn't noticed before, in which case you make a note, and you probably have to do some support work outside of that lesson so that they can then make more sense of that particular learning at a different point. On the other side, you may want to extend some children. In this case, I had plenty of opportunities for the children to be extended. I didn't need, with the cohort of children that I have, I didn't need any more, but you can always ask them to flip a question, to make up a fractions of amount pyramid, for example, to explain how to make links between fractions of amounts and fractions as operators. So how 2/3 of 12 is the same as 12 times 2/3, and try to show that pictorially as well. You can go to, this will all be shared, but you can go to this Key Stage 2 reasoning problem solving questions. There's quite a lot of good questions there with the answers as well. And also, if you go to Enrich, always a great resource to tap into. There's a whole load of resources for being a good mathematician and to be a good thinker. So great, great places to find challenging problems. Obviously, you have to find that before you teach the lesson, or after, but I don't think after will work. You will never find the right one that quickly. So that's that in terms of my input. And I think now it would be great, and I think it would be useful to you, I hope you find it useful, if you worked together. So if you go to Miro.com, and ideally if you download the app is easier so you can edit. I'm going to, you will find a screen like this. I will show you how to do it in a second, but there is one for each year group, year 2 to year 6, and they are all the first lesson on geometry. I've put all the small steps for White Rose Maths there as well. That's the scheme that we tend to use. We are fans. And I've also put an example of the premium resource that could be used. Obviously, we pay for these premium resources, so if you want them, you'll have to pay for them yourselves. But I've just put a screenshot of one example. I hope White Rose Maths won't mind. I'm advertising for them. And So what I would like you to think is, for that particular first question, what could be your anchor task? What would be the strategies that you want the children to learn, if any, in that first lesson? How would you support? How would you challenge? And kind of have a conversation like that. I am going to try, and if you tell me, I don't know how to make this work, but I can try setting up some breakout rooms if you would like to, or you can just simply type onto this Miro app. In fact, let me show you how that can be done, because sometimes it's a little bit complicated to see. Where is it? Why can't I get up? Okay. Let's see. You can't see my screen at the moment, I don't think. I can see there's some people there already. If you have done a webinar before with me, you will have seen this before. Let me try to share this again. Share screen. Can you see the screen now?
Yeah.
Yep, excellent. Oh no, not anymore. Or can you? I don't know.
Yeah, I can see it, yeah.
Now you can see it, excellent, thank you. So if you want to go to year 2, you just zoom in and then you can type inside. On the app, without the app, I don't think you can edit, okay? Can I send the link? Yes, I can, bear with me on the chat. Now, if anyone is interested in doing a breakout room, I'm very happy to set that up. Otherwise, I can see you working, basically. Just spend the next 10 minutes. It's now almost 20 past 5. Just 10 minutes looking at what you would do and just typing up some suggestions. This board will be open for a while. You can't see the link. Oh, did I respond privately? Hold on. I'm used to using Teams, I'm afraid, sorry. I'm not used to Zoom, as you can see. Right, so. Now let me see if I can see people. Yep, I can see Fikra is there. And I can see other people trying to get in. Do let me know if you're finding it hard. In an ideal scenario would be all in the same classroom trying to produce this resource that you can use in your own year groups, but that is not to be, sadly. Let me just log in again, I apologize. If it's not working for anyone, for some of you, please let me know. Oh, yes, I can see it now. Oh, I can see it properly. I don't know if I'm sharing. Oh, you are sharing. Okay, great. With access. I don't know how this works. Okay. Do type on the chat if you would like to ask anything, or if you want me to type something for you, you can't edit it. The reason I've put the White Rose Math worksheets there is that so that you have something to work from. Doesn't mean that you should always use it. That doesn't mean you need to use White Rose Maths. I just thought going into trying to plan something blankly, it would be quite difficult. So I thought I'd give you something to start. Lovely. So year 6 have got a what's the same, what's different approach. Pictures of angles, which one is the odd one out? Year 3 is starting to do some work as well. If you're in year 2, your first objective is to recognize 2D and 3D shapes. In year 3, the first lesson is to turn, trying and failing to type on Miro. Oh dear. Sorry, Sophie. Do you want me to, if you're not on the app, you probably won't be able to type. Would you like me to type something, or if you type on the chat, I can easily add to it?
Well, I'm sat here with Kate and we both teach year 3, and we were just thinking about how we could come up with an anchor task for year 3, and we thought maybe photos of angles in real life, and they could tick which ones show different angles or something along those lines. It's not quite refined yet, but something along those lines.
That's how we start. Lovely. Thank you, Sophie. I've just tried to type, and I'll make it bigger so we can all see it and see if my spelling is correct. Yep. Photo of angle in real life. Yes. But what would be, do you think, your question? What would be the open question that you would ask?
Let me think about that. I'll come back to you in a second.
It could be any, I can give you some ideas. It could be what's the same, what's different, true or false, and you can have a statement. It could be what's the odd one out?
Yeah, that would be a good one, I think. Yeah. What's the one out?
What's the odd one out? So when I did the webinar on variation, one of the things we talked about was having lots of examples, so examples of what you would call the like this, the regular way of seeing a particular shape, then having examples that, like for example, the way to explain it better is if you think of a pentagon, you will think it as the house shape, right? But I could show also a pentagon that doesn't look like that, but it is a pentagon. And then I can show a non-example, like a square or an X or a hexagon, that is a non-example, so that the children can explain their thinking and why it is that one thing is and the other one isn't. So have a think of that as well.
Great, thank you.
Welcome. Let's see, it looks like no one's in year 4. I will leave these boards open kind of forever, so you're welcome to use them with your teams as well, if you want to. Let's have a look here. I can't really see what it says. Same angle being measured by a protractor and safe position. What great mistake has, yes, what's the mistake? I love that there's a STEM sentence there, measuring angles. For example, the position, the point, something, at something, make sure that blah, blah, blah. So they come up with their own. Lovely, thank you, Tasreen. I think I'll give you another 2 minutes. At 25 past, we will just wrap up quickly. It's just more to get you to think about. It's not as effective as it would be if we were in the classroom. You're only able to view, Gemma. Do you want, which one are you looking at, Gemma? You can't speak either, I don't think. I'm only able to view year 5, okay. Oh, right, so that's a bit annoying. I can try to invite you if you let me unshare, and if you private message me your, oh, now I'm sharing or not, I don't understand what I'm doing now. You are screen sharing, stop share, that's what I want to do. Okay, right, board doesn't exist. So Gemma, you're in the app as well. Oh dear, I don't know. Are you on a phone? Sometimes on the phone it doesn't work. I don't really know how to solve that technical issue, I'm afraid. It's not my area of expertise. How about Jennifer? I can try to invite you if you private message me your email, I can do copy invite link. Let's see if that works. I put the invite link on the chat and see if that makes any difference to anyone. Or I can enter an email here. Right, I think I'm happy to stay a bit longer after if people want to have a discussion about more things. But I think for the purposes of today, I might just reshare my screen, but go back to the presentation if I manage to do so somehow. Right, so I'm going to share my screen and I'm going to share this desktop. I don't want this. Are you able to see my screen?
Not yet.
Not at the moment.
Okay. Gosh, I really am not good at this in business, am I? Let's try that again. Why can't I share my screen like this? Right. Put this here. No, that's not it. I just want to wrap up so that people who are done can go. I don't really know. Technology. Right. Desktop. Let's try that. What about now? Still no?
No.
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 Why?
No, sorry.
I will persevere. Bear with me. How about now? Oh no, it says it's failing. Okay, wait. I will not give up. Bear with me. How do I do this? Share screen. This. How about now?
No, sorry.
No.
Oh my gosh. Why? Oh,
Yeah, got it
It's
now.
working.
Yes.
It's working.
right. Is it working if I press this button as well? Does it work?
Yeah.
Yes. Okay. Right.
It's
So
smaller. It's small now.
it's small.
It's smaller after you've pressed that button. It's into the smaller slideshow. Yeah, that's better.
That's better. Okay. Right.
Yeah, I can see it properly now.
Thank you. Thank you for your patience. Right. So to wrap up the question that I put at the start, and that's the title of the webinar, can less really be more? In my opinion, yes. With less kind of time spent on fluency and rote learning, you get less unmanageable marking of different worksheets and not as wide a gap between lower ability and high ability. What you do get more of is children engagement, because everybody feels included, because everybody really wants to learn maths. So that leads to more confidence in the subject and in learning the subject and teaching it to others as well. More opportunities for assessment for learning, which leads obviously to more secure learning outcomes. A deeper understanding of the mathematical concepts using mathematical language, the collaboration through extension. And if you're spending less time marking, hopefully you have more time to plan, to carefully plan for these lessons in order to show some variation. If you are interested to learn any more, this will all be shared. There's lots of articles and all sorts of things that you can read on. And that is that from me. If you have any questions, please ask. And please, at the end, if you wouldn't mind giving some feedback through that QR code, I would really appreciate it so that I can make it better every time. I hope you've found it useful, even with the technical difficulties. Jennifer, I will add you as soon as I've finished with this technical side so that you can at least see it later. But that's it from me. If you have any questions or any suggestions or anything else, just let me know. Thank you.